Yes, in this video, I'm going to discuss about the factors which are influencing the polarization of the covalent bond under the chapter 4 of structural theory in organic chemistry, that is of degree first semester. We'll discuss, I'm going to discuss in detail about the inductive effect in this video. Yeah. Before going to the factors which are influencing the polarization of the covalent bond, I've already discussed about this bond polarization in my previous video. Just in brief, I'll give you in one line what is bond polarization. This bond polarization is nothing but the electron displacement or the electron redistribution in the bond pairs. So the bond polarization can happen by means of inductive effect or mesomeric effect or hyperconjugation. It can happen by these three kinds of effects. And let's know about what is inductive effect and how it is happening here in this video. So I'll take an example of N-butyl chloride in order to understand in detail about this inductive effect. So N-butyl chloride is the 4 carbon atoms which are attached in a straight chain with the Cl towards end. Yes. And this, when we take an example of this N-butyl chloride, let's number these carbon atoms. This is 1, 2, 3, and 4. And the Cl, we already know that it's highly electronegative as a halogen. It's more electronegative when compared to that of the carbon atom. So it tries to draw the electrons from the C1 carbon atom. And as a result, this is going to get the partial negative charge, and this is going to get the partial positive charge. Because of the high electronegativity tendency of chlorine atom, it is trying to draw the electrons from the carbon chain by means of sigma bond. So this is a sigma bond. So this carbon here is sp3 hybridized. So one of this sp3 hybrid orbitals is linked to this carbon atom, and other two to the 2 hydrogen atoms, and one to the Cl atom. So it's drawing the sigma electrons towards it. So so the sigma bond electrons are involved in this. So this C1 atom now is become the positive charge. Now this in turn will try to draw the electrons from this C2 carbon atom. Yes, C2 carbon atom, and in turn this will get the positive charge here, but this time it is less than what is expected. The partial positive, which is double partial positive, which means that it is less positive when compared to that of the C1 atom. Now this C2 carbon atom will in turn tries to draw the electrons from this 3,3 atom, which in turn will get triple positive, that is less when compared to that of the C2 atom. What do you think now? Is the C3 atom trying to draw the electrons from this? It's very less. It's almost negligible or not counted. Even if it draws, it's very less, and the transmission is almost getting negligible as we are going towards the end of the carbon chain. After C3 atom, it's almost negligible. Yes. Now, so as the length of the chain is increasing, as we are moving towards the end of the carbon chain, from the Cl atom, the effect is decreasing. See, the effect is decreasing as we're moving from Cl towards the other end. The C1 atom is more positive when compared to that of the C2, when compared to that of the C3, and getting negligible as we move towards the C4 carbon atom. Yes. Now, what is inductive effect? Let's know about this inductive effect now. Yes. So, so the bond polarization, which is causing In the ClC bond, that means the bond polarization, because of this electron attracting tendency of the chlorine atom from the C1, is in turn causing the effect at C1, C2 atom, which in turn is causing the effect at C2, C3 atom. This is what is bond polarization, I mean the inductive effect. So the bond polarization of the sigma bond, due to the bond polarization of a sigma bond, is called as inductive effect. So the bond polarization of this bond, because of the bond polarization of the adjacent bond, is called as inductive effect. The bond polarization here is causing the polarization in turn at the other positions in the carbon chain. Yes, the C bond polarization is responsible for C1 C2 bond polarization, and this is called as inductive effect. And let's look at the characteristics of this inductive effect. Yes, I've already said this. See, involves the sigma electrons, because this is the sigma bond electrons. See, this is effect is more here, which can be shown by an arrow, because this is little less and this is more less, and this becomes negligible as we move towards the C4 carbon atom. It involves the sigma electrons. And the second one is the permanent effect, which is seen in the ground state of the molecule, and it can be shown in many of its physical characteristics like dipole moments, melting points, boiling points, etc. And one more thing, the effect is decreasing as the distance increases, as the length of the carbon chain is increasing as we moving farther from this electron withdrawing group, the effect is decreasing. Yes. Yes, and yeah, I've already discussed this. So let's draw at the conclusion of this definition now. Yes, the bond polarization, I mean, the inductive effect is nothing but the bond polarization which are involving the sigma electrons. It's a bond polarization, type of bond polarization, but it involves the sigma electrons here, or electron redistribution is taking place, again involving the sigma electrons. So the electron redistribution or the electron displacement, which is involving the sigma electrons, is nothing but the inductive effect. Now, the inductive effect can be of two types. It can be minus I and plus I effect. Now, the Cl group is more electronegative than carbon atom, so it's an electron withdrawing group. It tries to draw the electrons from the carbon chain. As a result, this is getting the negative charge. Such type of groups are called as minus I groups, minus inductive effect groups. And the effect which is caused because of this minus I groups is called as minus I effect. So the Cl atom is trying to draw the electrons from the carbon chain, or trying to attract the electrons from the carbon chain towards itself, which is transmitted through a sigma electrons and which is inducing the partial positive charge on the carbon chain, is an minus I effect, and the groups are called as minus I groups. Yes. And when we look at the order of this few of these minus I groups, that is, which are trying to attract the electrons from the carbon chain, or from the system to which it is attached, are Nr3 plus. It is the highest, it shows the highest effect because of the positive charge here. It tries to draw the electrons from the carbon chain more when compared to that of Sr2, and then comes the neutron molecules, and then carboxylic acid group. And then the halogens. Last is the phenyl group. And let's look at now the plus I effect. What is plus I effect? Let's look at it with the help of an example here. Now, this O minus now is an electron releasing group. It releases the electrons into the carbon chain here. It is releasing the electrons into the carbon chain. As a result, this is getting the partial positive charge, and the carbon next to it, let's number them as 1, 2, 3, 4 again. This is getting the partial negative charge. So the effect is more in the first bond, and the effect decreases as we move away from the electron releasing group. This is getting the partial negative charge, and as a result, this C2 will try to draw the electrons from the C1 carbon atom, which in turn will get the partial negative charge, but this time it is less than C1 carbon atom. And C3 will try to draw the electrons from C2, which is much less, and then as a chain is transmitted, it becomes negligible or zero at C4 carbon atom or not seen at all. This type of effect, which is shown by the electron releasing groups, is called as plus I effect, and the groups are called as plus I groups. This is because plus I groups, the group is getting the positive charge because of its electron releasing nature. So this is a plus I group, and the effect which is caused by this is a plus I effect. And again, the same characteristics holds good here. This is transmitted through a carbon chain with a with the sigma electrons or through the sigma bonds, and it's a permanent effect. And as the length of the carbon chain increases, as we're moving away from the electron releasing group, the effect is decreasing. So the plus I effect decreases or becomes negligible as we move towards the C4 carbon atom. Yes, when we look at order or of this plus I groups effect, decreasing order of this plus I effect, the first comes is the O minus. Because of its negative charge here, it wants to get rid of this negative charge, so it tries to give away the electrons towards the chain. So comes first in the order, then comes the carboxylate ion, because to some extent it is because of the conjugation, it comes second in the order, and then comes the tertiary butyl group, alkyl groups, and then secondary, and then primary, and the last is the hydrogen. I'm going to discuss the order of this stability of the carbocations in my next video about this alkyl groups. Yes, and then last one, this Ingold method. He arrived at a method to make us easy about this electron releasing and withdrawing groups. If we take this as a reference, for example, this hydrogen as a reference here, which is attached to Cr3. If this Z, H is replaced by Z here, if the electron density increases on Cr3 because of this electron releasing nature of this, such groups are called as plus I groups. And if the electron density is increasing, decreases on Cr3 because of its Z, because it is an electron withdrawing group, then such groups are called as minus I groups. Yes. I repeat it here. If H is replaced by Z, which is an electron releasing group like O minus, Cr3 is going to get more negative charge. That means electron density is increasing on Cr3, and such an effect is called as plus I effect, and these groups are called as plus I groups, plus inductive effect groups. And if this Z is on electron withdrawing group like Cl, for example, Cl we have taken, the Cr3 is going to get the positive charge. That means the electron density is decreasing on Cr3, and Z is an electron withdrawing group. Such groups are called as plus I groups and the effect minus I groups, and the effect is called as minus I effect. Yes.